Hello guys and welcome back. So we have finished the hands on both left side and right side. We have the joint group, controller group, and that overall controller group. Let me group them together. It's going to be called left hand rig GRP, and then for the right hand it's the same thing, joint controller and then overall controller. Group them together, right hand rig GRP. Alright, two groups created. Let me then parent those two things underneath the Sophia rig group. So now if you look at the hierarchy, we now have 4 groups, 2 for the left and right arm and 2 for the left hand and right hand. Alright, we have another problem after organizing it. When we rotate the arm, the hand doesn't really follow. Okay, the reason for that is because the hand group is, independent from the higher hierarchy. To make it follow though, it's very easy. Just grab the driver joint of the wrist and then the group of the hand, this one, and do a rigging, constraint, and then parent constraint. That will make it follow. Alright, let's do the same thing for the other side. Just the driver joint and then the hand group, constraint, parent, and we're done with the hand follow. Alright, now let's move on to the span. For the span, we're going to do the same thing first, which is duplicating the joint chain. Because the span starts from the root, we're going to duplicate the entire joint chain. But I don't need to see the side, and let me isolate it. I don't need to see the side or the clavicle or the neck. I don't need those. All I need is this joint chain for the span, so I deleted everything else. And then I also need to unparent it and then probably make them bigger by changing their radius so it's easier to see both joint chain. Alright, and then let me go for a modify, search, and replace names to replace the name from JT to JTDRV. Alright, and then I can go delete that number there. Okay. Now to control this joint chain, I'm gonna use a different IK called a IK span handle. And this guy, we're gonna just use the default settings and click at the beginning and then the end of the joint chain. That will create a IK handle and a curve. Let me rename this IK handle IK span and then curve span. Okay. And then for the curve span, let's see how this IK works. So this IK works like this. So every time when you change the shape of the curve, the IK joint chain or this joint chain here will always try to match with the shape of the curve. But of course sometimes it can't. It doesn't shrink, but it will try to match with the shape of the curve when it changes. And that's the only way you can use this IK to control it. So to control it, then we need to control the shape of the curve. To do so, the easiest way is applying clusters. So let me grab the top 2 control vertex and do a deform cluster, and the bottom one also a deform cluster too. I will end up with 2 clusters. I'm going to rename this one on the top, cluster handle span top, and then the bottom one, of course, cluster handle span bottom. Okay, now I can animate those 2 clusters to change the shape of the span. But that's really hard to select, so I need controllers. Let me go for a circle here. And this one will be called AC root. And then I'm gonna group it. And then call it AC root group. Okay. And then grab the group and the root joint, doesn't matter which one it is. Here. And then do a modify match transformation, match all transform to move my group there. And then I can grab the vertices, make them bigger, and then rotate them this way. Alright, so that's gonna be my first controller. Duplicate it and holding down V to move it up. I'm gonna snap this new one to the chest or the first joint of the rib cage. And this one is gonna be called AC chest. And AC chest GRP, of course. Alright. And then duplicate it again, move it to the middle. It doesn't have to be exactly in the middle, so somewhere here. Okay, I'm gonna call this one AC span. And AC span GRP. Alright. And one more from the root, duplicate it, and this one will be AC hip. Alright, and then let me put them underneath their hierarchy. The chest will be underneath the span, and span will be underneath root, and then hip will be underneath root too. Okay, so that's gonna be the hierarchy here, and you can see that the hip is now overlapping with the root, so they're the same shape. I'm gonna isolate it and then grab some of the vertices and maybe reshape it to make it looks like the pelvis. Okay, maybe smaller. Alright, and then for the chest, it can be looks like this, or I can also reshape it to make it cover this entire chest area, like so. Okay. Alright, so that's the chest controller's shape. Alright, after that, to make them control the cluster, all we have to do is grab the cluster and parent the cluster underneath the controllers. The top one will go underneath chest, the bottom one will be underneath the hip. Okay. Now we can use our controller to control the joint channel. Okay. Alright, let's see that in real action here. Let's grab the controllers, the joint, and then the driver, the binding joint. We can apply our control from driver joint to the binding joint. But I'm not gonna do the first one and then the last one, only for the middle ones. So this one here and then the one below it, beneath it. Let's do a parent constraint. Okay, the same thing here. Okay, the reason I don't do the two ends, this one and then the first one, is because it's very unstable to make the driver joint to control those. I'm gonna actually use the controller to directly control them. So controller first and then the joint, and then do the parent constraint instead. For the bottom one, it's gonna be the hip controller, and then hip joint or the root joint, do constraint parent. Alright. So now I can rotate my controllers to control the span. My arm doesn't follow, it's very easy to do. And for now we can just grab all 4 of those groups and then middle mouse drag them underneath the chest, just to temporarily make them follow. Alright, now I have a working span now. I can bend in all sorts of directions. I can control the top and the bottom separately, and I can use the root to control everything. Okay, so that's the basic of the span. Now let's move on to something else. One of the problems you can see when you animate this chest controller or the hip controller is that they cannot twist when you drag it this way to twist it. Let me actually show the rotation axis. When I rotate the controller, it doesn't twist. Now there is a way to twist it underneath the Aki handle, which is this attribute called twist. So that's how we twist it. To make it work with the chest, all we have to do is, using node editor here, let me clean it up, drag the Aki in and then also drag the controller in. So all we have to do sorry, is actually just use the rotation, let's see, rotation X to control the twist here. Alright, so that way we will make it twist properly, but that doesn't support the twisting of the hip. So let me also grab the hip in, and then let's kick this one out. That's the hip controller. For the hip controller, we're gonna do something a little bit more complicated. So it's gonna be the rotation X. Rotation X will be controlling roll. What that does is now when I rotate the hip, everything rotates with it. And then I want to reverse twist it back. I need a multiply divide, and then connect the rotation X to the input 1x, input 2x will be -1, and then the result goes to the twist. That's gonna break the one from the chest, but let's just make this one work first. Let me call this multiply divide, hip, twist. Okay, so now if I rotate the hip, the twisting works too. So the mechanic here is that using the rotation X to roll it, that will make it follow, right? But we want to twist the top back, so that's why we apply a negative value, multiply the rotation X by -1 to twist the top back. That's how it works. Now to make them all work together, we just need to add the chest twisting and then the hip twisting, add those two values together. Okay, so that requires a plus minus average node. Let me rename this one twist, span twist. Okay, open it, and rotation X goes to input 1D. The result, I don't need that anymore. Okay, the result of the multiply divide, output X goes to input 1D1. Okay, and then the operation will be adding those two together, which is the default settings, so we don't need to change anything here. The output result goes to the twist. Alright, that's gonna be everything we needed. When that is done, we can now twist both the top and the bottom, and they will all work together. Okay. Alright, so that's twisting. Another thing we don't have is stretching. So when I drag this up, the span doesn't get longer. They're all staying that way. So the only thing changes is the location of this one, this joint here. So how do we fix that? Well, we just need to know how much the curve has stretched, because when we drag the controller up, the curve here, it's a curve span, which was created when we apply the IK handle, also changes its length. We just need to know how much it has changed and then apply that much amount of scale on those joints, and we will get we will have the joint also stretching the same amount. Alright, so let me minimize drag it in. It has a bunch of things here. I don't really need that. I don't need the original shape. All I need is its actual current shape. I need to know its length. That's gonna be a curve info node. I'm gonna rename it. It's one curve info span current. Okay. To get the original length, let me actually connect this together first. I can press 4 button to open this guy. That's gonna give me this input. Connect that to the word space 0 of the shape here, and then the arc length will be the length of this curve. Alright, let me zero out my controller here first before I duplicate it. So to get the original length, I can either remember this value here, it's let's see, that value here, 17 something, or I can just duplicate this guy and then call this new one origin. And because this one is a duplication, it doesn't change shape when we drag the controller, so it's always going to be the original length. Alright, so let me grab its shape here. and then I need another curve info, so Control D to duplicate it, press 4 to open the input curve attribute, and then connect workspace 0 to input curve. Alright, now we have two curve info. This one is going to be renamed origin. So this is the original lens, that's the current lens. All we have to know is they're different. I'm going to use multiply divide to divide those two values. Operation will be divide span stretch. Okay, and then the arc length goes to input 1x from the current. Input 2x will be the arc length of the original lens. So what we're doing here is divide the current length by the original length. That's going to give me how much more it's going to be stretched up or squashed in, and that output x will be applied on the scale of those joints. Okay, so let me grab those joints here and then pass those in. And let me open the scale. Oops. And all we have to do is connect the output x to the scale x. You can just pass that along the joint chain by just grab the previous joint scale x and connect it to the next one, because they're all sharing the same value anyways. Alright. Now if I drag the controller up, you can see now the joint stretches with it. Now there's a little thing hidden here. We're applying that scale on the driver joint. Okay, so when we drag things up, the driver joint chain becomes longer because we're scaling those joints. If you go see their value, but if you go grab the original binding joint, they're not scaling up at all. But they're changing location because they're they're being parent constrained, but not scale constrained. And it has to be that like this. If you don't, it will have a weird, stretching at the bottom and the top. So that's why we do that on the driver joint instead of the binding joint. If you're curious, you can try that. It's not gonna give you a decent result. Okay, so that's the scaling part of the joint chain, and that's everything we did in class to set up its spine rig. But there are more things we can do. When you drag this controller up, or what you will also expect if it's real world is that you want it to be thinner in the middle too. Just like when you drag a a rubber band, it will get thinner when you get when it being stretched longer. So that part of the thing is something I want you to try to achieve. And it's gonna be count as extra credit. If you can do that, I will give you 4 extra credit, 4 solid points. So what that means is it's gonna bring you from B+ to A, or even from a D to C something. So it's really important. So I want you to try that, figure out how to do that. A little hint is that you just need to figure out what's gonna be for the scale X, scale Y and Z, but not on the driver joint this time. They're gonna be actually on the binding joint. Okay, so you have to apply or calculate the scale YZ for those binding joint, those two values, and then to calculate that, you have to use this value, the scale X. The more scale X's of those driver joints, the lesser scale YZ will be on those joints. But the relationship here is not that simple. For example, if the output X here is 4, meaning that the joint chain is getting 4 times longer, that's gonna mean the scale Y and Z are getting 2 times smaller, if that makes sense. So the volume maintains the same. Alright, so I leave that for you to figure out, and anyone who have that in their assignment will get 4 more extra credit. Okay, and that's for today's tutorial, and I hope you all enjoyed it, and I will see you in the next time.